Hi guys, welcome to Just Coding YouTube channel. Last couple of weeks we are seeing the lead code problem. So today also we're going to see one of the lead code problem. And this is kind of a favorite to me and very interesting one. Okay, all you have to do is square root of the integer. This is our job. Okay, let's see how we do it. Okay, let's first read the description. Okay, given a non-negative integer x, return the square root of x rounded down to the nearest integer. The return integer should be non-negative as well. You must not use any inbuilt exponent function or operator. Okay, so here we have two catch. One is you must not use any inbuilt function. Okay, that is fine. Second thing is rounded down nearest value. Okay, in the rounded down, this down is important. For example, let's take an example 24, 25, 26. Let's say this is our input. Okay, if you ask to find the square root value, you'll easily say it's a 5. For this, you will say again 5 because 5 is almost like near to that value. Okay. But for this, you cannot say 5. Why? Because they said rounded down to the nearest integer. Okay. For 24, the actual, if you go with the decimal, it will be like 4.9 something. If you down the value of 4.9, it will be 4. So for 24, it will be 4. Even though it's near to 25, it is a 4. That's the output they expect. Okay, so these are the two catches that you have to aware of. Okay, let's take a simple example. Okay, let's say I want to find the square root value of 10. Okay, I want to square, this is my input. I want the square root value. Okay, so what you have to do is first we have to set the limit from min and max. How long we going to iterate from 0 to till how much? Till I don't want to go till 10 because we are 100% sure that it should be minimum like lesser than the half. Okay, so we can go from 0 to 5. That's the maximum limit we can go. Okay, then even if it's 0 to 5, I don't want to go by one. Okay, let's say if it's 10 million, what will you do? Will you go by one? No. We need an algorithm. Okay, instead of going by one, we have to go by step. Okay, the step by step is like each iteration, we have to cut down the limits by half. For example, if it is 0 to 100, the next iteration should be 0 to 50 or 50 to 100. Okay, in next iteration, it will be 0 to 25 or 75 to 100. So we have to cut down the size by half of each iteration. Okay. Then our time complexity of this will be log n instead of O of n. Okay. That's very big. It's faster. Log n is faster. Since we are cut downing each iteration by half of, it will be faster than the O of n. Okay. Let's take a simple example 10. Okay. I know that the limit will be 0 to 5. Okay. Let's put an array 0, 1, 2, 3, 4, 5. Okay, my minimum is 0, max is 5. And how long I want to iterate is till minimum is less than or equal to max. Until this condition satisfied, I want to iterate. Okay, my iteration logic will be first thing is I want to find the mid value. Mid value is nothing but min plus max by 2. Here our case will be 0 plus 5 by 2. It is nothing but 2. So our mid is here 2. Okay. So mid is 2 is nothing but we will just square the value 2. So we'll get 2 square is 4. If 4 is lesser than the 10 or bigger than the 10, it is lesser. Okay. So since it's lesser, what we have to do is we have to change the minimum. So what you do? Minimum will come to here. One step plus than mid. So nothing but min, it will be mid plus 1. This is what happens if the value is lesser. Our value is lesser than the input. I want to do this. Okay. So the min will go to here now. Here my new limit is 3 to 5. That's what my limit. Okay. So what I'll do, let's say, I'll erase the thing. This is my min. Max is still 5. Okay. Now do the same operation. Find the mid. 3 plus 5, 8. 8 by 2, 4. Okay. So this is the mid now. Okay. So mid 4 square is 16. Now 16 greater than input or lesser than it? It's greater than input. Okay, so it means we went too far. Then we have to retrace from little. Okay, then this max will go one step lower than the mid. So nothing but max equal to mid minus 1. So the max will go to here. So it means now max and min both is pointing to 3. Okay, let's see what happens next. So our min is 3, max is 3. Okay, if you find the mid also 3. Okay, now square the value of 3. So 3 square will be 9. It is lesser than our input value 10. 9 less than 10. So if it is lesser, what we do? We will move the min to the next. Okay, so what to do? The min will move to 4. Okay, by the time it moves, here we are breaking the condition. Min is no longer less than or equal to max. Okay, then we have to see what was the last value index, that mid. Where was the mid at last? So it was in the third. Here only it was there. Okay, then 3 is the nearest square root of 10. Okay, let's try the coding. Let's see how it will go. Okay, first we write the our corner cases. Okay, if x double equal to 0 or x double equal to 1, return x. This is to avoid the corner cases. Okay, and min equal to by default 0, max is nothing but x divided by 2, and we have one more thing called, okay, where is that output? Let's say as of now it's 0. As I said, our loop will go on until min is less than or equal to max. Okay, and our first bit, mid value, finding the mid value. So I will find min plus max divided by 2 and our square value. So val will be mid star mid. Okay, the reason why we are putting long is, as you can see, the limit is 2 power 31. It's almost like max of integer value. Okay, let's say that is the value. Okay, if I want to try to square the off value of the max value, it will be definitely it's larger than a max value. Okay, then you will get a negative value. To avoid that, what we're doing is we are just declaring this mid and value both as a long value, so that any cases it will not violate the integer max and min condition. So for safe corner, if the limit is they mentioned as the largest of integer, it's better to go for the next level, long. If the limit is long, okay, then go for a higher, like double, like that. Okay, we got mid value, we got the square value. Now what we have to do is our first condition, if value is double equal to x. If so, return the mid. But as you can see, the return value is integer, so I'm just converting to int and type. Okay, if you directly find let's like 24, like 25 and 625, in that case and all, we'll directly find the value. Okay, if else value is less than the x. So if it is lesser, what we have to do, we have to push the min to the next level. Okay, so min will be mid plus 1. Okay, same. If value is greater than x, okay, it means we went too far. Then what will do? Will max equal to mid minus 1. Okay. And I'm going to add one extra line here. Output equal to mid. The reason why I'm adding this line here is, okay, let's say as we see that the last example, okay, when we are in 3, it is below like 9, the square value is 9, lesser than the input value. Okay, when we go for the next step, it will be obviously more than the 10, it will be gone next 16. Okay, in that what we did is we check what was the last mid value that was lesser than our thing or it's related to. Okay, so this is what that condition. Okay, so by mentioning this, okay, if sometimes if we are lower but suddenly we go higher, it means that we are in dilemma. If you one step lower, it's very low. If you one step higher, it's very high. Then what would be the thing? Okay, since we want to with a down value, integer down value, that's why we put this output equal to mid here. In case, suppose the output says, the description says round at the up value. For example, 24 and everything, okay, they go, I want 5, not 4. Square root of 24, I want it as a 5, not 4. That means round it up. In that case, all you have to do is just copy and paste it here and comment it here. That's it. So that's how. If the same question, if you take with a down and up, okay, all you have to do, if it is down, put it here. If it is rounded up, put it here. That's it. That's one trick. Okay. Since our current thing is down, I'm just putting here. I'm just commenting out here. Okay. Then finally, I'm returning the output value. So output is still integer, so no problem. Okay. Let's try to run and see any build error or anything. So it accepted. Fine. Let's submit. Yeah. Oh, it's 20 seconds and we beat almost like 83% of other users. Okay. So that's it, guys. Okay. If you have any clarification or you have any better idea than this algorithm, please comment it out. Okay. I'll reach out to you. Or if you have any other problems you want me to work it out, please let that also know. I'll try to create a video of that. Okay. Thank you, guys. See you in the next program. Bye.